In this video, we'll explore how the Moon, our closest celestial neighbor, controls the mighty oceans of Earth. From the science behind tides to their impact on ecosystems and human life, this journey will reveal just how powerful the Moon truly is. Before we dive into the depths of this celestial dance, don't forget to subscribe to Orbit Watchers for more cosmic revelations that bridge science and myth. The Moon's silent command. Every day the ocean breathes, a slow, rhythmic inhale and exhale that shapes coastlines, dictates marine life, and influences human activity. This perpetual motion, known as tides, is orchestrated by a celestial conductor, the Moon. Though distant and silent, the Moon's gravitational pull exerts a profound influence on Earth's waters, creating a mesmerizing interplay between the heavens and the sea. Human civilizations have long been aware of this influence, embedding the Moon's powers into myth and legend. Polynesian cultures revered the moon goddess Hina, attributing to her the tides and rhythms of the sea. In Greek mythology, Selene drove her chariot across the night sky, thought to stir the ocean's moods. Hindu traditions honor Chandra, the moon god, as a force guiding the water's rise and fall. Yet, as poetic as these stories are, the reality of the moon's effect on the seas is deeply rooted in science. Understanding the physics behind tidal forces allows us not only to marvel at nature's elegance, but to anticipate and adapt to its patterns. The mechanics of tides. Gravity's embrace. Tides result from the gravitational forces exerted by both the Moon and the Sun on Earth's oceans. Despite the Sun's immense mass, the Moon, being significantly closer to Earth, has a more substantial effect on tides. As the Moon's gravity pulls on Earth's oceans, it creates bulges of water, the high tides, on the side of Earth facing the Moon and the opposite side due to inertia. As Earth rotates, different areas pass through these bulges, experiencing the rise and fall of sea levels. This gravitational interplay leads to two high tides and two low tides, approximately every 24 hours and 50 minutes, a cycle known as semidiurnal tides. However, the exact timing and magnitude of tides can vary based on the Moon's phase, Earth's rotation, and the alignment of the Sun, Moon, and Earth. Continental landmasses and seabed contours also distort these patterns, giving rise to complex regional differences in tidal behaviors. Spring and neap tides, the lunar cycle's influence. The Moon's phases significantly impact tidal ranges. During full and new moons, when the Earth, Moon, and Sun align, their combined gravitational forces produce higher high tides and lower low tides, known as spring tides. Conversely, during the first and third quarters of the Moon, when the Sun and Moon are at right angles relative to Earth, their gravitational forces partially cancel each other out, resulting in neap tides with less extreme differences between high and low tides. These cyclical variations in tidal ranges are crucial for coastal ecosystems, navigation, and human activities such as fishing and recreation. For example, spring tides can flood estuarine zones, delivering nutrients that stimulate plankton blooms forming the base of the marine food chain. Neap tides, meanwhile, offer calmer waters that are often exploited for harbor operations and certain shellfish harvests. The Moon's reach beyond the ocean's surface. The Moon's influence extends beyond the visible rise and fall of sea levels. Tidal forces contribute to ocean currents, which play a vital role in regulating Earth's climate by distributing heat across the planet. The Gulf Stream, for instance, is bolstered by tidal dynamics and helps keep much of Western Europe warmer than other regions at similar latitudes. Additionally, the friction generated by tides, known as tidal braking, slows Earth's rotation over long periods, gradually lengthening the day. This process also causes the Moon to slowly recede from Earth at a rate of about 3.8 centimeters per year. Over geological timescales, this recession subtly reshapes the dynamics of Earth's orbital relationship with its satellite. Tidal rhythms also govern the life cycles of countless marine organisms. Horseshoe crabs spawn on beaches during spring tides. Coral species time their mass spawning events with lunar cues, releasing gametes in synchronized bursts. Even some coastal bird species time their feeding patterns to tidal lows, accessing mudflats teeming with invertebrates. In modern society, understanding tidal dynamics is also critical for engineering and urban planning. Coastal infrastructure must be built with tidal ranges in mind, and accurate tidal forecasts are vital for shipping lanes, offshore drilling, and disaster preparedness against storm surges. Furthermore, tidal movements also influence groundwater levels in coastal aquifers. During high tides, seawater can infiltrate shallow groundwater tables, a phenomenon especially relevant in regions experiencing sea level rise due to climate change. Understanding these interactions is crucial for managing freshwater resources and preventing saltwater intrusion into potable water supplies. Another important effect is the potential for harnessing tidal energy. As global demand for renewable energy grows, tidal power presents a consistent and predictable energy source. Coastal regions with high tidal ranges, such as the Bay of Fundy in Canada, have already begun utilizing this force through underwater turbines and tidal barrages. These technologies convert kinetic energy from tidal flows into electricity, contributing to a cleaner energy future. The Moon's enduring legacy. The Moon's gravitational pull orchestrates the ceaseless ebb and flow of Earth's oceans, demonstrating the profound interconnectedness of celestial and terrestrial forces. This dynamic relationship not only shapes our planet's physical characteristics, but also influences ecosystems, human culture, and our understanding of the universe. Through tides, the Moon silently governs the pace of marine life, sculpts coastlines, drives oceanic circulation, and influences the Earth's own spin and tilt. Its legacy is written not only in folklore and religious texts, but etched into the geological and biological systems of the planet. By appreciating this connection, we become more attuned to the balance of forces that sustain our world. We also uncover the Moon's potential to help power our societies and guide us in water management strategies. And as science continues to uncover the nuances of lunar influence, we are reminded that even the quietest celestial companions can have the loudest voices in shaping life on Earth. If you found this exploration of the Moon's impact on the sea enlightening, subscribe to Orbit Watchers for more journeys into the wonders of our universe.